integrations. In this webinar, we discuss the basic terminology of battery, the working principles, their classifications, and how to measure the dimensions and their ratings and specifications also. Okay. The today's session is focusing about the battery pack, and also in BMS we can discuss about the SOC, state of charge, SOH, state of health, and different terminology and key functions of BMS. Then we discuss about the series parallel combinations. You can see in a battery pack, the batteries are connected in different way in a series or parallel combination. So how to calculate how much cells are connected in series and how many numbers of cells are connected in parallel, and both series and parallel, how to get connects each other, and define this is the battery pack of 12 volt or 14 volt or 7 to 78 volt or 64 volt. So how to measure and how to they are connect in series parallel, they are discussing this webinar. So now we're going to our first point, the what is the battery. So we know about the battery. The battery is a chemical storage devices, means they are stored in chemical energy and then they convert to the electrical energy. In chemical form, we can use some liquid, some solid state. Okay. The chemical reaction is involved to flow of electrons of one circuit to another circuit, or one path, one direction, or one path to another path. These flow of current flowing through the external circuitry, these flow of current we can use as a charge, and we can use as a load, or we can use as a power. So in generally in electrical systems, we can use as a generator and alternator to generate the electricity. They converts mechanical or kinetic energy to convert the electrical energy. In battery, the chemical means different chemicals. In lead acid, the lead acid are used. In lithium ion battery, lithium are used. Nickel, the different chemicals are used to store in energy form, and we can use the electrical energy. So we can see in a picture, this is the two electrode. First is a positive, next is a negative, and they flow through the external circuitry, the electrons. You can see that this is a act as a charge, means the charge can be transferred to the cell, and in act as a load, the charge can be transferred to the battery to the load. Okay. The next one is the internal parts of the battery. We can see in a battery, basically the two parts are most of the major. Anode and cathode, we have calculated as a positive terminal and negative terminal. But some more components are inbuilt in a battery. First is the anode, we denote it as a negative electrode. Then cathode, we denote it as a positive electrode. Then it is an electrolyte. The electrolyte is a form as a liquid, also it is a form as a solid. The electrolyte is nothing but the lithium salt. The different electrode are used, but in this webinar we focusing about the lithium cells. The different lithium cells are used: lithium nickel, lithium pyrophosphate, lithium titanium, lithium. The different most of the 5 to 6 chemical reactions are in lithium form. So in this webinar we is focusing about the only a lithium part. Okay. In electrolyte, the lithium salt material are used for the electrolyte. They are allowed to flow the ions. Okay, positive ions, they can flow through the electrolyte. Then you can then second next is the use as a separator. This is a separator, you can see in a picture. The middle part is a separator. The separator provide to the direction of flowing through the ions through the anode to cathode or cathode to anode. The separator is provided to allow the flow of ions only, not the electrons. The electrons is only flow external circuitry. You can see the electrons only flow the external circuitry, but the separator is allow only ions to flow through the electrolyte. The electrons cannot be allowed the separator. Next, the separator most probably use the polymer material made as of polythenes and ethylene polymer materials, mixture of the polymer materials also. Okay, they can allow similar, they can allow to the electrons, positive ions only. The electrochemical reaction is formed in a discharging process or charging process. In a discharging process, the ions can flow cathode to anode. In discharging process, ions can flow cathode to anode and electrons to flow similar to the cathode to anode. In charging process, the current is flow cathode to anode and ions also flow in a flow of a electrolyte, only a electrolyte. The current cannot be allowed in an electrolyte. Why? Because using a separator. The next part is a lithium ion battery. So nowadays in electrical vehicle, most probably lithium ion batteries are used. Why? Because there are some few or major advantages of lithium battery. They can store maximum energy and maximum energy density compared to the another batteries. This type of batteries are the rechargeable battery. Lithium are is main characterized on main charge producible. The purpose of this battery are used to the for a safety purpose also, because there are fire safety. Why? Because they are in a fault occur in lithium battery, they are start to flame, means start to first of all the blow, and then they can be also transport to the high damages. They can also to provide this high flammable or damages to battery, we can use the BMS also. The battery is more expensive. Why? Because this is the rare material. These battery are used in a mobile phone applications, laptop, mobile phone applications is a power bank also, power tool equipment, energy storage system, and electrical vehicle. The advantages of this battery are high efficiency, high energy density, light in weight, high discharge current capacity, also high cycle count. Means the lithium ion battery goes to the approximately 1000 to 3000 cycle. Means the cycle means once you discharge and then charge. This is a cycle. Charge and discharge both are combined. This is the one cycle, and they give to the approximately 1000 to 3000 cycles. That's why the lithium ion batteries are most probably preferable in various electrical and mechanical tools also for the energy storage purpose. The classification of this battery are the classify into the charge storage and the shape and structure of the battery. The basic three classification has the primary battery, secondary battery, and specialized battery. What is meant by primary battery? The primary battery is nothing but the non-rechargeable. Means a few days ago we can use the non-rechargeable batteries, means cells, remote cells, clock cells. These are the non-rechargeable, means they can use one time and then you can dispose. Okay. The chemical structure, chemical reactions are the alkaline batteries and zinc carbon batteries. There are the chemical are used in a primary batteries. Next is a secondary battery. The secondary battery is a rechargeable battery. Rechargeable means once they are used, you can charge, then also use. Okay, it is a simultaneous discharge, charge, again charge, again discharge. This is a cycle. Now we can use the chemical reactions are lead acid batteries, lithium iron batteries, nickel cobalt batteries. The lead acid batteries now recently used in an inverter. You can see the most of the inverters are the lead acid battery. The two-wheeler, the IC engine two-wheeler and IC engine four-wheeler batteries. This is also made up as a lead acid battery. Now pure electrical vehicle we can use as a lithium iron and nickel cadmium batteries. The last third one is the specialized battery. This is a solid state battery and fluid batteries. They are specialized used as a specific application, like a satellite or any aeronautics engineerings. There are used the specialized battery. As per the classification of the structure of batteries, these three parts or these three types are classified. First one is a cylindrical, means is a shape as a cylindrical. You can see in a picture, this is a cylindrical shape. Okay, it is like a tank. This is a prismatic. You can see this is a prismatic. Okay, and this is a pouch cell. Pouch cell. You can see that as a pouch type. You can see this is a battery used as a mobile phones. Okay, you can in a mobile, these pouch cell batteries are used. So these are the specifications of different battery cells: cylindrical, prismatic, and pouch cell. You can see this is a cylindrical cell. The specification is NCR 18650. What is denoted as? This is the number. The 18. The 18 is indicate the diameter of cell. 18 mm. 18 mm. It is indicate diameter of cell. And 65 middle two digit indicates the length of the cell. Okay, this is the length of the cell. Sorry, this is indicate length of the cell. This is a nomenclature. Next is a prismatic cell. You can see the specifications are NCA 793540. You can classify it as a two sections, means 793540, 793540. The 779 is indicates the width of the battery. Okay, thickness, width of the battery. 7.9 mm, it is width. Okay, 35 mm, it is a length. 40, it is a height. Clear? Similar to the pouch cell, UPF 496171Z. This is the specification of pouch cell. Similar, first two digit are the width, second two digit are the length, and 71 is the height. 4.9 mm. All these are in mm. 4.9 is width, 61 is the length, and 71 is the height. You can see any cells, these specifications are mentioned. So you can understand what is the size, what is the length, what is the height of a battery pack. Why we are discussing this topic? Sir? Because we can sorry.
Sir,
sorry.
Sir, I'm Kalidas. One doubt, sir.
So after the completion of this webinar, 1 hour.
Okay, sir.
Okay, no issue. Thank you. Please complete this webinar. After that, we can discuss about the everyone doubts and question answering. Okay.
Okay.
Okay, thank you. The cylindrical cells are Nominal voltage is 3.7 volt. Capacity is 3350 milliampere-h. Nominal in prismatic cell, the nominal voltage are 3.6 volt. Capacities are 1515 milliah, and pouch cell our capacity is 3440 milliah. Okay, these are the capacity or ratings of this battery. The different cells has a different specifications. In this, you can see in a picture. In this picture, we can consider as a which company, Samsung or Panasonic. These cells are the Panasonic cells. Consider in this picture. The different company has a different diameters, different cells, and different size and weight, and also has a different rating also. The most probably the cells are manufactured as a 3.6 or 3.7 volt. Okay, depends upon their structure and specifications. The next part is the chemistries used in electrical batteries. We can discuss as early as two. In most of the electrical vehicles, we can use the lithium ion batteries. This is the different chemistries of lithium ion batteries, and these are the you can see these are the classifications or different parameters of each batteries. The first is the lithium nickel cobalt aluminum oxide. Next is the lithium nickel manganese cobalt oxide. Next is the lithium manganese oxide, lithium titanate, and lithium iron phosphate. In most of the cases, LFP batteries are used. Each company decide their own specification. Some companies are decide my specific energy so much high, so some company collect the NCA battery, lithium nickel cobalt battery. Some company has been made the highest safety battery, they goes to the LFP battery. Okay, you can see this is a comparison of all these 5 chemistries of lithium. Okay, in the first lithium nickel cobalt, you can see the cost is low but specific energy is high, specific power is high, safety comparatively low, performance is moderated, and lifespan is high. Compare this all these 5 as per our requirement, we can select the battery. In nowadays, the Tata or most of the EV vehicles are used the lithium iron phosphate LFP batteries. Okay, in European countries, most of use NCA batteries. Okay, depends upon their chemistry and depends upon their requirement. Each company has specific standard. As per that standard, they decide which battery are used. But most probably, the lithium cells chemistries are most probably used. The next part is the BMS. Now we discuss about the BMS. The BMS is nothing but the heart of the battery. BMS is battery management system. They provide protection of battery against the different abnormal or faulty condition, like over voltage, over current, under voltage, over voltage mana. So temperature also, the humidity also. These are the fault. The provide the protection against this fault. Use the BMS. The BMS is a electronics component for the using different electronic switches to provide the protection. Nowadays, the smart BMS also used to control the battery pack, also to control the temperature. What is the objective of the BMS? They provide protection of fault and prevent the battery damage. Means any fault is occur in a battery, goes to the high temperature, over voltage, over current. This is damage to the battery. To provide protection against this, we can use the BMS. They can provide, maintain the reliability state of the battery, calculate real-time data, generate report according to the data, and monitor to a charging and discharging. Means the battery current exceeds their specific value. The BMS can indicate to the consumer the battery can drag the overcurrent. So we can take the precaution also, we can reduce the temperature, and also some BMS take action by own using the thermal management system, cooling system. Okay. This is the specific, or this is a drift about information of BMS. Now, the types of the BMS, basically they classify into two types, hardware BMS and software BMS. The first is a hardware BMS. It is a basic protection function of battery pack to provide protection against over voltage, under voltage, continuous current, over temperature also. This is a software BMS. The software BMS are used provide the data. Okay, so BMS both, so hardware BMS and software BMS both are providing protection, but the software BMS providing the data by the using of the CAN communication and Bluetooth. They are also continuously monitoring and continuously given to data to the consumer for different functions like state of charge, state of discharge, state of health, cell balancing, communication interfacing, and data logging and reporting. This is the advanced smart BMS functions we can discuss in the state of charge. The state of charge, it is indicates the energy stored in a battery. It is very important factor because there are display what is the remaining capacity of the battery. Next is a depth of discharge, means it is indicates the discharge of the battery. Means suppose the battery is 60% charge, means 60 is the SOC, means 60% charge is remaining, and 40% is the discharge, means it is a DOD, depth of discharge. Okay. Next, data logging and reporting. It is provide recording historical data about the battery performance, events, and condition, which can be used for analysis and maintenance. Also, BMS can provide the cell balancing. The individual cells have some different, so their charging and discharging performance slightly different. Each cell cannot be ideal. That's why the cell balancing is required. Next is the state of health. The state of health is provide capacity storage of the battery. The communication interfacing. The BMS is a new in a smart BMS. The host can view and host can see the inside specifications and inside parameters of the battery by the using of the communication interfacing. In communication interfacing, we can use the Bluetooth or CAN communication. Next is the cell monitoring and diagnosis. BMS can analysis to the what is the value of overcurrent, over voltage, and they can continuously measure and detect the fault, and they automatically diagnoses. For example, consider the battery temperature is goes to the beyond the limit, means its limit is goes to the 100 Celsius. So BMS is automatically on the cooling system. Okay, these are the fault diagnosis process. Next is the type communication of the BMS. CAN communication, control area network. It is a robust vehicle bus standard designed to allow microcontroller and device to communicate with each other application without hosting a computer. It can also be implemented for a communication between battery charge and battery management system. And next, the new things is the IoT, Internet of Things. This is the new technology to communicate with the battery by the using of the internet. Bluetooth is used as a approximately goes to the 50 to 30 foots, but IoT you can use as a wide range also. It required wireless, but it internet through the transmitter. The data can be stored in a cloud, so we can fetch the data different as per our convenient. This is a ultra Bluetooth. This is a universal asynchronous receiver and transmitter compiled with the Bluetooth interfacing. In this BMS, we can control by the using of the various app by the connection of the Bluetooth. We can disconnect the cell, connect the cell. We can arrange the different levels of the voltage. This is a BMS topologies and architectures. Basically, three types of architecture. First one is the distributed BMS architecture. You can see in a picture, this is a cells. Each cells or each small group of cell provide each BMS. And these BMS are connected to the central controller. The central controller is nothing but the microcontroller. Okay. The next one is the modular BMS. You can see the BMS can classify into different parts. You can see in a picture the battery pack is divided, and these divided battery pack are coupled to the BMS, and these two BMS are connected to the central controller. The next is a centralized BMS architecture, means in this battery pack or in this cell cannot use the different BMS. Use only a one BMS, and each cells are connected to these BMS for the monitoring, balancing, and controlling functions. These are the specifications of the BMS. Each BMS has different specification, depends upon the load, voltage, current rating also. Okay. In this specification, we can discuss about the, you can see about the voltage, discharge current, maximum current, cell balancing type, over voltage, under voltage. These are the levels of the BMS, specification of the BMS. The reason of the failure of BMS, first is a short circuit and overheating. The electric shock within the BMS circuitry cause the immediate failure, means high short circuit current flowing through the BMS. It can be failure of the BMS. Sensor malfunctioning, means sensor cannot operate properly, so BMS can be failure. Moisture and humidity, means water content or humidity materials parts is caused the BMS functions. It will happen the some corrosions. Next is the farm updates. Is incorrect and incomplete farm update to provide introduction view and issue of the failures. Component qualities. In a BMS, we can use in a low quality material is defect the component and fail the normal operating condition of the BMS. Means these are the reason the BMS can failure. Now we can go to the main point. Our main webinar point is the battery pack designing. So to design the battery pack, these materials are most of used. You can see in the first, battery cells are used, battery holder spacers, okay, to provide the fix, okay, use the battery cells. Next is an interconnector or bus bar. We cannot use the wire, it is used as a bus bar. Next is a BMS. This is a BMS. Next, insulating material. This is the insulating material. Why? Because we can use the insulating material. So the earth fault or any short circuit will present in a BMS or in a battery pack. The current will flow through the outside of the battery or outside of the shield. To provide this protection, we can use the insulating material. The insulating material are the most of used as plastic or epoxy resin. Okay, most of use the epoxy resin. Next is the enclosure. You can see in a picture. This is the enclosure. This is a connecting wire, and this is the final battery pack. Okay, this procedure can follow to design the battery pack. This is the configuration of series parallel. As you can know about the inner batteries are connected in series. Batteries are connected in series. The voltage can be increases, but capacity are same. Means current rating, AH rating are same. You can see in series connection, battery positive terminal is connected to the next positive terminal. Negative connect to the positive. Negative connect to the positive. It is connect the alternatory. Okay. Negative, positive, negative, positive, negative, positive. The series connection voltage can be increased. Means this is a parallel configuration. You can see in a parallel configuration, batteries are connected in an across way. Means each cell has a positive terminal connect. Each cell negative terminal connect. In this parallel configuration, voltage are same, but capacity are added, increases. You can see in a series connection, voltage are added, capacity are same. But in parallel connection, voltage is same and capacity is added. Okay. This is a series parallel combination. As per the requirement and as per the battery pack specification, we can use the different series parallel combinations. So how to decide how many cells are connected in series and how many cells are connected in parallel? So this is the next part of this. This is a modeling of the EV batteries. First is the cell. Next, they are assembled in parallel. They generate the modular, then sub-modular, and then last is the battery pack. Okay. So in this way, we can connect or design the battery pack. First, we assemble in parallel, then modular assembly, and then battery pack. So this is the battery pack designing step. First, we calculate as a series cells. I mean, number of cells are connected in series. How much number of cells are connected in series? Next one is the parallel cells. How much parallel cells are connected in cells? Find the number of cells, and then we'll connect as a series parallel combination. In a series cells, we can find as a battery voltage divided by current cell. In parallel, battery pack capacity divided by cell capacity. And number of cell we calculate as a number of cell is equal to series cell multiplied by parallel cells. So we can give into the one example, battery pack designing of 12 volt 5 Ah ampere. Okay, so this is the battery pack design. So we can I can take the one battery pack specification. Okay, we take the one battery pack specification. Which one? One second. Okay. So first we can goes to the first cylindrical cell. The voltage is 3.6 volt. Okay, and capacity is 3350 H. Okay, this is the cell specifications, and by the using of these cell specifications we can design the battery pack. So approximately we design the 4 to 5 battery packs. So okay, now you see, first we calculate the series cell. Sorry, series. What is the formula of series cell? It is a battery pack voltage. Battery pack voltage divided by cell voltage. Divided by cell voltage. What is the battery pack voltage? The battery pack voltage is 12 volt. 12 volt. And in a cylindrical pouch, okay, in cylindrical cell, okay, we can see the CEC, cylindrical cell. What is the specification is 3.6 volt. Right, it is a voltage, and current capacity is the 3350 milli Ah, right? So milli can be converted into Ah, milli Ah converted into Ah means 3.350 Ah, right? This is the capacity and this is the voltage. So voltage is 3.6 volt. What is the value? 12 divided by 3.6. It approximately goes to the 3.33, right? So cells are not in point, na? So we can give as a 4 number of cells in a series. The second is the parallel cell. Okay, parallel cell. The parallel formula is, you can see, what is the parallel formula? Battery pack capacity divided by cell capacity. Battery pack capacity. Okay, we can only capacity. Okay, then cell capacity. Cell capacity. What is the battery capacity? Battery capacity is 5 Ah. 5 Ah. And cell capacity is, this is donated, 3.350. What is the value? 5 divided by 3.350. It goes to the 1.49. So round up this value, we go to the 2 number of cell. Okay, means is series is goes to the 4 number of cell, in parallel is goes to the 2 number of cell. Then we calculate the number of cell. Number of cells. So number of cells is formula series cells multiply by parallel cell. Okay, the how much connect in series cell? 4. In parallel 2. 4 into 2, 8. Means number of cell designed to this battery pack 12 volt 5 Ah. We required the total 8 cell. Okay, so now we design the battery pack. So in a series, in a series, how much? In a series cell, how much? 4, right? In a parallel, how much goes to the 2? In first, we connect as a parallel. Okay, how much cells are connected in parallel? 2. Okay, this is the battery cell type. positive, negative. This is the second, positive, negative. 1, 2. Parallel connected to the 2. The positive connected to the positive, negative connected to the negative. This is the positive terminal. Okay. The two cells are connected in parallel. Two cells are connected in parallel. Now connect in series. The 4 cells are connected in series. Means these parallel combination are in 4 times. Means see in a picture. This is the okay. This is the first. This is the second. This is the third, and this is the fourth. The parallel configuration, it goes to the 4 times. Okay, clear about that? Okay, this is a positive, negative, positive, negative, positive, negative. Okay, next negative connect in series connection. We can discuss about the negative connect to the next positive, negative, positive, negative, positive, negative, positive, and these are the terminals. And this is the next. So this is the positive terminal, positive, and this is the negative. The measure, this is the P0, B0, battery B0. This is a B1, this is a B2, this is a B3, and this is a B positive or B4. These are the terminal. These terminal are connected to the BMS. They, how to connect? Let's this discussion in the next point. So now we can calculate as a 12 volt 5Ah battery. Okay, simple way. First calculate the series cell. What is the series cell formula? Battery voltage divided by cell voltage. The battery voltage is 12. Cell voltage goes to the 3.6 volt. Okay, this is approximately go to the 4. Similar. The capacities are different. This is a parallel cell. What is the formula? Battery capacity divided by cell capacity. What is the battery capacity? 10, and cell capacity is 3.350. It goes to the approximately 10 divided by 3.350. It goes to the 2.985. It approximately go to the 3. So how to design? The parallel is the 3 and series is the 4. So calculate number of cell in battery pack. Okay, battery pack. So series are 4 multiplied by parallel are 3. It goes to the 12. In previous numericals, we can see the number of cells is the 8 cell. In this battery pack, the number of cells are goes to the 12 cells. Okay, so design this battery pack. Similar, sorry. Series is goes to the 4 and parallel is approximately goes to the 3. Yes, right? Okay, 3 and 4. Right. parallel. So first connect in parallel means how much cells are connected in parallel? 3. These are 3 cells. Positive, negative, positive, negative, positive, negative. 3 terminals are connected in positive. Okay. And this is the 1. And we can connect as a series. How much are series? 4. This is the 4 times. Okay. This is the 4 times. Okay. The positive are connected to each other across. The negative are connected to each other across. Sorry. Okay. This is the second one. This is the third one. And this is the fourth one. In series connection, this is the first positive terminal. This is the negative connected to the next positive, positive, negative, positive, negative, positive, negative. Negative terminal connected to the positive, negative connect to the positive, next negative connect to the next positive, and this is the last negative terminal. We calculate as a B, denote as a B0 or B negative. Sorry, B0 or B negative. This is the B1, this is the B2, this is the B3, and similar this is the B4, and also then denoted as a B positive. You can see this is the difference. Okay, this battery pack has a 2 parallel. Okay, why? The capacity is low, 5 Ah. In this battery pack, the capacity is double, is approximately goes to the 10 Ah. So parallel is the 3 cells. Okay, similar you can calculate the E cycle battery pack, 24 volt, 10 volt in series connection. Series is goes to the battery voltage. We can go to slightly fast way, divided by cell voltage. The battery voltage is 24 volt, cell voltage is 3.6. Okay, 24 divided by 3.6. 24 divided by 3.6 is goes to the approximately 6.66. So we take as a 7 in parallel. Battery capacity divided by cell capacity. What is the battery capacity? Is 10 Ah and cell capacity is 3.350 Ah. So 10 divided by 3.350, it goes to the 2.9. It is approximately considered as a 3. So number of cell in battery pack, is 7 into 3. 7 into 3, 21 cell. Okay, the 21 cells are used to create this battery pack. 24 volt 10 Ah battery. These battery are using E cycle batteries. Next is a battery pack of e-bike, in two-wheeler bike. This is the fourth example. Find the series cell. Formula is battery voltage divided by cell voltage. The battery voltage is 48 volt divided by cell voltage is 3.6. So what is the value? 48 divided by 3.6 is goes to the 13.33, approximately considered as a 1/4. In parallel cell, formula is the battery capacity. divided by cell capacity. Divided by cell capacity. The battery capacity is 20 Ah and cell capacity is 3.350. It goes to the value 20 divided by 3.350. It approximately goes to the 5.9, means considered as a 6. Okay, then find the number of cell in battery pack. So series cell multiplied by parallel cell. Series is 14 and parallel is a 6. 14 multiplied by 6 is goes to the 84. 84 number of cells are used in this battery pack. Okay, so you can clear the picture how the series cells are found, how the parallel cells are found. To both series and parallel, we calculate the battery pack. Okay, these are create the huge battery pack. Okay, and how they are connect to the BMS. This is the structure. You can see in the picture. You see, this is a B negative. The first is the B1. This is the B2, and last terminal is a B positive. So how they are connect? You can see in the picture. Last battery pack. Okay, this is the battery pack. B0 or B negative. This is a B1. This is a B2 terminal. This is a B3, and last is a B4 or B positive. These battery pack are connected to the BMS through this. This is a 3S. What is S indicate? S is indicator series. Okay, means 3 cells are connected in series. Okay, and how they are connected in motor? You can see the battery positive terminal goes to the P positive, and this is the P negative is connected to the BMS negative, P negative. B is denoted battery and P is connected to the supply. Okay, this is a 3S, means 3 series and 12 volt. Similar, we design the 7S. What is meant by 7S? Means 7 cells are connected in series. Okay, this is the battery pack, BMS. This is the BMS. Okay, this is the 7 terminals. First is the B negative. Negative terminal is the negative. Next, this is a B1. This is a B2. This is a B3. Goes to the B7, and last is the B8. Nothing but the B positive. And how do they are connect? The B positive, battery positive, is connect to the direct to the load, motor or charging side, and B negative is connected to the battery pack or BMS also. Okay, different BMS has a different connection. Okay, in most probably Samsung, Panasonic, Delhi, these are companies are made the BMS. Each BMS has different connection, but the battery connections are each BMS are same. You can clear this. Now this is the battery pack designing with a BMS integration. Thank you all of you. Any questions?
Sir, yes, sir. Kalidas.
Okay, 1 minute. Yes.
Sir, you said that the cylindrical, prismatic, and pouch cells, sir.
Yes.
The size indications, the first 2 digits are the base, first 2 digits are thickness and height and width you said, no, sir?
Yes, yes. Depends upon the company manufacturing. No? Each company has made
Okay, sir.
their own specifications. But
Okay, so there is no standard for it, sir.
sorry.
There is no standard or fixed size for it. There's a company's demand.
No. There is no any standard for the dimension.
Okay.
No any standard.
Okay, sir.
As
Okay,
for
sir.
you can build your own company and you can
Okay, sir.
build your own EV. You can design single cell in whole battery pack.
Okay, sir.
Each company and each cell manufacturers. If any
Okay,
questions,
sir. Okay.
please put in chat box also.
Okay, sir. Thank you.
You can clear about that, how to calculate the number of cells, how to connect the series and parallel.
Yes, sir.
Okay, thank you so much. It is informative to you, all of you?
Yes, very informative.
Okay, thank you so much. Okay, anyone hesitate about any question, please put in chat box also. I can answer it every questions also.
Hello.
Yes, sir.
Sir, I have a query that can you repeat again regarding that flow of lithium ion during charging and discharging?
Okay, I will take the last question of this. Why? Because the theoretical part is more. That's any other questions? No any issue. I will take this question.
And sir,
yes.
Another thing that suppose if a battery has a 40% SOC and 60% SOH, how we just define on that?
So state of health is 60%. Na? So 60 is calculate compared with the 40. It is find as the 40% SOC.
Sir, that means it will charge up to initial whatever that energy capacity is there. So it will charge up to 60%.
Sorry.
That means if battery capacity has an initial suppose any type of initial energy capacity, if the SOH is 60%, that means up to only that the capacity should be 60% of the maximum capacity.
Okay, so your question is that the battery can charge up to the 40%, right? SOC.
No, I'm stating that SOH.
SOH.
H. Yes, sir.
State of health is 60%.
Yes.
And SOC is
50%.
60. Both are 60.
No, 50, sir. SOC is 50% and SOH is 60%. How you just define on that? That means
your question put in chat box. I can answer it. Okay, please put. I can understand. Okay. I can give you the answer. So next we'll take the question, what is the scope of fuel cells in battery electric vehicle? Yes, it is a future of in fuel cell also. Cylindrical cell dimensions. Okay, wait. So this is the cylindrical cell dimension, right? Okay. These first two, 18 mm. This is the diameter. Okay. Next two, 65 mm. It is the height or length. Okay. This is the diameter. Okay. This is the diameter of. The diameter is 18 mm. And height it is a 65 mm. Clear? Similar to that, this way. In 79, this is a 7.9 mm. Next 35. This is as a considered as a 35. Last is this is a 40. All these are in mm. Different company has a different specification as their own standard manufacture. Okay, clear? A relation. Okay, next. SOC is 50% and SOH is the 60%. So, okay, wait. Okay, yeah, I will start it. One minute. In
can produce an inverted output voltage. So that is what the current. So here the DC to DC.
Hello.
yes, sir.
So we use a switch that rapidly turns on and turns off to control the output. So here the unit section.
If you have any question, you can ask from the trainer. They will guide you better. Anyone having any questions, please ask. You can also use chat box. Okay, so before we continue, we will like to play a brief video that introduces ISI India and the impactful work we are doing in the field of electric mobility. So here I am going to share a video of ISI India. Please watch that.
As we are living in the fast-changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, e-bike design challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youth for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQ courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero Motocorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Calcutta University, Sharda University, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop the workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
For those who are interested in deepening your knowledge and skills in electric vehicle, we are offering a comprehensive courses. You can easily scan this QR code, and our executive will contact you shortly about the courses, and they will guide you much better for which course you should go. Thank you for joining the webinar. I hope you have found a session very valuable, and we look forward to seeing you in future webinars and courses. Thank you, everyone.
Sorry, about the certificates.
Certificate will be issued in your registered mail ID.
Sir, excuse me, sir. Any feedback link?
No, sir, no feedback link.
Okay. So shall we left?
Yes, yes, you can left.
Thank you, sir.
Thank you, sir. Thank you for this opportunity.